Hello, today we will be talking about horizontal and vertical asymptotes. You can think of these problems similar to inequalities and piecewise functions where you are approaching a point but you actually never touch the point. Where if you have, for example, x which is less than 6, then your line will show that you would actually never touch 6. However, you would approach 6. And that's very similar to what an asymptote is. But rather than it being a singular point, it's actually a line. So in this line, your line will approach, let's say, 0, but it'll actually never get to 0. Let's take a classic example with 1 over x. And with 1 over x, you have this graph where this is your point 0, 0, and your graph would look like this and like this. Although this line approaches the x-axis, it actually never touches the x-axis. And similarly, although this line and this line approach the y-axis, it will never touch the y-axis. And that is the definition of an asymptote. Sometimes when dealing with asymptotes, you'll see statements that say as x approaches some value with a negative sign in the exponent, and then sometimes you'll see as x approaches some value a with a positive sign in the exponent. And what this means is the a with a negative sign in the exponent is approaches from the left, and an x and a value with a positive sign in the exponent means it approaches from the right. What this means, if we have x approaching 0 from the left, then that means we are going from the left to the value of 0. As x gets closer and closer to 0, our value of y goes to negative infinity. F of x, or this function, approaches negative infinity. Similarly, if the question asks if x approaches 0 from the right, then what we see here is we're going from the right to 0. And as x approaches 0, then we see that this value of y, or f of x, actually goes to infinity. So f of x goes to infinity. So again, what we see here is that the function f of x actually never touches, in this case, the horizontal axis or the x-axis of 0. Similarly, it never touches the vertical axis or the y-axis at 0. Those are both known as asymptotes, and then if we approach a point, in this case 0, from the left and or from the right, we'll get different values depending on the function that we're looking at. Now that we understand terminology, let's look to see how we solve for horizontal and vertical asymptotes. All right, for horizontal asymptotes, if you're looking at the function, let's say f of x equals g of x over h of x, and g of x follows a to the n, x to the n plus a to the n, so a typical polynomial that we've seen divided by another polynomial, then we can use 3 rules that we have here to help us identify the horizontal asymptote. In those rules, we're taking a look specifically at the exponents of the function in the numerator and the exponent in the function of the denominator. Looking at the first rule, we see that if n is less than k, then y equals 0, or the x-axis is our horizontal asymptote. The next rule states if we have n is equal to k, then the line y equals an, that is the leading coefficient of the numerator of that polynomial, and you're going to divide that by the leading coefficient in the polynomial in the denominator. and that is going to be your horizontal asymptote. Our last rule states if n is greater than k, then there's going to be no horizontal asymptote. Looking at this first rule, we can use our example that we had earlier, which is 1 over x. In this case, n is equal to 0 and k is equal to 1. In this case, 0 is less than 1, so we have n is less than k, which means we can use this first rule to state that y equals 0, which we know if we graph this, y equals 0 is this one here, is the horizontal asymptote. And looking at the graph that we had 1 over x, we know that that is indeed an asymptote because it never touches that line there, or it never touches the line there. Looking at our next rule, we need to understand when n is equal to k. If we have 5x squared over 10x squared, then we know that the line y equals an, so the leading coefficient, so that's going to be this one, divided by bk, which is the leading coefficient in the denominator, and that's going to be our line. So we know that the horizontal asymptote is going to be equal to y equals 5 over 10, or 1/2. If we graph this, we're going to move it up here to the top. Then we're saying at 1/2, so we'll say this is 1. At y equals 1/2, this is going to be our horizontal asymptote. And this graph will not cross over this line. All right, looking at our last rule, we have if n is greater than k. If we do that, then say we have 5x to the 5th divided by 5x to the 3rd. In this case, we have n, which is equal to 5, and we have k, which is equal to 3. In this case, n is greater than 3. And what this tells us is that there is no horizontal asymptote. If we were to graph this out, we would be able to reduce, and we would just actually get a parabola. This parabola, however, would have an open circle here because it can't touch 0, but the hole is there because it says that it can't touch that point. If you plug in a 0 into this function right here, then it's going to be undefined at that point, and that's why we put a 0 there. However, because you're able to simplify this down and reduce it, this is actually going to reduce to x squared, and that is why we get a shape of a parabola that we're used to. However, because this isn't the function that we're graphing, we're actually graphing this function here, we have to take into account the limits of the denominator. So any value in the denominator works, excluding 0, and that's exactly why you have an open circle here, because it's undefined at that point. We'll look at some more examples, but I just wanted to point that out at this time. But those are the 3 rules. Again, if n is less than k, then y equals 0 is the horizontal asymptote, or the x-axis. If n is equal to k, then the line y equals, and you take the leading coefficient of your greatest power in the numerator, and then you take your leading coefficient of your largest power in the denominator, and you divide them by each other, and that's going to be your horizontal asymptote. And then the last rule we have is if n is greater than k, there are no horizontal asymptotes. Now that we understand horizontal asymptotes, let's look at a few rules for vertical asymptotes. For vertical asymptotes, this is pretty simple. All you'll need to know, if you have the function f of x and it's equal to some an x raised to the n plus an minus 1 x to the n minus 1. You continue that. Similarly, you have bk multiplied by x raised to the k power plus bk minus 1 multiplied by x raised to the k minus 1 power, and you continue that. All we need to do for vertical asymptotes is focus on the denominator. We know that the denominator cannot equal 0 ever because that is an undefined function or an undefined value. And so simply to find the vertical asymptote, you just need to set your denominator equal to 0, solve for those zeros, and then that will be your vertical asymptote. It's important to note that you'll need to know how to factor, and so if you need a refresher on factoring, I will link videos in the description below. If you had, for example, 3x to the 7th plus 6 divided by 2x plus 1 multiplied by 3x plus 2, then your vertical asymptotes would be these factors here set to 0. So one of your asymptotes would be 2x plus 1 and equals 0, and then another one of your asymptotes would be 3x plus 2, and we're setting that equal to 0. When you solve for x, you're going to move the 1 over to the right-hand side, divide by 2, so x equals a negative 1/2. And then similar on the second asymptote, you're going to solve for x, so you move the 2 to the right-hand side, divide by 3, and we get negative 2 divided by 3. And these are our two asymptotes. If you were to graph this out, this is what x would equal. So we would go, if this is 1 here, we would have an asymptote, a vertical asymptote at this point of negative 1/2, 0. And then we would get our second asymptote at negative 2/3, which would be here, and that's equal to negative 2/3, 0. So this tells us that the graph will not touch any one of these lines. If we look at another function, let's say we have the same numerator. This time we have a denominator that is x squared minus 3x minus 18. Then in this case, all you would need to do is factor this down. This factors into x minus 6 and then x plus 3. If we wanted to check, we would have x squared, we would have a 3x, we would have a negative 6x, add the negative 6 and the 3x together, which gives us a negative 3x, and then negative 6 times 3 is negative 18. So these would be our factors. From here, we would just set these equal to 0, so x minus 6 equals 0, and we would have x plus 3 equals 0. When we further solve, we will get x equals 6, and we will get x equals negative 3. If you graph these out, these would be your vertical asymptotes at 6, 0, and we would have the other one at negative 3, 0. Okay, now that we understand some rules for asymptotes, both vertical and horizontal, let's look at a few examples that will combine the two. All right, looking at this problem, we have the function f of x equals negative 2 multiplied by x plus 5 multiplied by x minus 6, and we're dividing by x minus 3 multiplied by x minus 6. And the question asks us to find any vertical asymptotes, horizontal asymptotes, or any holes that exist. Because vertical asymptotes are relatively easy, let's start with those first. With vertical asymptotes, what we need to remember is that we can't have a function that's divisible by 0. So if we take the denominator and set those terms equal to 0, then we should be able to find the vertical asymptotes. Because this problem is already in factored form, we don't have to factor the polynomial that would be in the denominator, so that helps us out. But what we also see here is that a factor in the numerator is similar to a factor in the denominator. That's a good indication that we're going to have a hole in this problem rather than an actual asymptote, because again, the numerator and the denominator will cancel each other out. So at that specific point, we can't have a zero in the denominator. However, the remaining values still work. So with that, in our vertical asymptote, all we need to do is simplify this problem. So we have f of x equals negative 2, x plus 5, and divide that by x minus 3. We have in the denominator our term x minus 3, and we set that equal to 0. Again, we don't want 0 in the denominator because that's an undefined function. We solve for x, so x equals 3. This tells us that we have a vertical asymptote at x equals 3. If we wanted to graph that out to see what it looks like, then what we know now is if this is 0, 0, then at 1, 2, 3, we have a vertical asymptote here. If we didn't have common factors in both the numerator and the denominator, we would also need to solve for x minus 6 and set that equal to 0. But again, because we're able to simplify the problem, then we know that that is actually not a vertical asymptote. However, we do know that x minus 6 does play a role. And because of that, if you do not simplify the problem, because the original function has the value x minus 6 in both the numerator and the denominator, we do need to account for that. So to account for that, we're going to solve for our holes in the problem. And in this case, again, because we're looking at common factors, which is that x minus 6, that's all we're going to focus on. If we set x minus 6 equal to 0, because again, that's an undefined function, then we get x equals 6. If we plug 6 into the function f of x, then we're going to be the function at 6 equals, simplifying the problem, we're able to again remove the x minus 6, so we get a negative 2 multiplied by 6 plus 5. Again, that top term of x minus 6 cancels out with the bottom one, and then we're left here at the bottom with 6 minus 3. When we simplify, we get negative 2 multiplied by 11, and we get 6 minus 3 is 3. When we further simplify, we get f at 6 equals negative 22 over 3. This tells us that at the point 6, negative 22 over 3, we're going to have a hole, because at 6, negative 22, 3, this function f of x is undefined there. If we want to graph to see what that looks like, then we'll draw another graph here. And we will go 1, 2, 3, 4, 5, 6. We have our vertical asymptote at 3. And then at the point 6, negative 22 over 3. So we'll just call this point 10 here. So we'll go up 7 1/3. So we'll say it's about a point about right here. And that's going to be an open circle, which then means the graph will go and approach that point, but will actually never touch that point. All right, next what we need to do is see if this problem has any horizontal asymptotes. We remember from our rules that if we have the value of n, which is less than k, then our x-axis is going to be our asymptote. If n is equal to k, then we know that the leading coefficient of the numerator divided by the leading coefficient of the denominator will be our horizontal asymptote. So we have a to the n divided by b to the n, and that's going to be our asymptote. And lastly, if we have n which is greater than k, there is no horizontal asymptote. Looking at the problem that we have, if we do foiling, we see that in the numerator, we have x squared as our largest term. If you need a refresher on how to FOIL, I will link a video in the description below. But essentially, you take the x multiplied by x, you're going to get x squared. X multiplied by -6 plus x multiplied by 5 is going to give us negative x, and then 5 multiplied by -6 is going to give us -30. What we see there is we have that x multiplied by x, which is x squared. So in this case, n is equal to 2. And then we do the same on the denominator, where we have x multiplied by x, which is going to be x squared. And that is our highest degree there as well. So k is equal to 2. And what we see in this problem is n is equal to k. When n is equal to k, we know we need to take the leading coefficient of our numerator and divide it by the leading coefficient in our denominator. The leading coefficient is that -2 multiplied by what we just did, x squared minus x minus 30, and divide that by x squared minus 9x plus 18. Distribute that -2, we get -2x squared plus 2x plus 60, and divide that by x squared minus 9x plus 8. Taking the leading coefficient of our numerator and taking the leading coefficient of our denominator, which in this case is a 1, then all we need to do is do -2 divided by 1, and this is equal to -2, and this is our horizontal asymptote. With that, all we need to do is go up to 2, if this is 2 here, and we draw our asymptote. And really this should be a dotted line because it's not a point on the graph, it's just a asymptote, which means that the graph will not go to this point. And then I am making this up, but let's just say the graph looked something like this. Which would say the graph does not touch this asymptote here, but it approaches this asymptote. It does not touch this asymptote here, but it approaches the asymptote. And then the graph does not actually go to this point here, but it approaches that point on either side and then continues to go. And those are our answer. This is where the hole is located in this graph. This is where the horizontal asymptote is located. And this is where the vertical asymptote is located. Okay, let's try one more problem. All right, we have the function f of x equals -4 divided by x squared minus 4x plus 4. And the problem asks us to find if there are any vertical asymptotes, any horizontal asymptotes, or if there are any holes in this graph. Because vertical asymptotes are the easiest, let's start with that. What we first need to do is find our factor of both the numerator and find the factor of the denominator. In the numerator, it's only -4, so there are no factors with respect to a polynomial. However, in the bottom, we do see that this can factor to x minus 2, x minus 2. With that, we know that the vertical asymptote is when the denominator is equal to 0, because we can't have a factor that has a denominator of 0. In this case, it's x minus 2 with the multiplicity of 2, which just means we need to solve for x minus 2 and set that equal to 0. When we solve for x, we get x equals 2, and that is going to be our vertical asymptote. Now we are going to look for holes in the graph. We do not have any factors that are in the numerator and the denominator. Therefore, there is going to be no term or factor that cancels out, and therefore we have no holes in this problem. Again, if we had an x minus 2 in the numerator and we were able to cancel out one of the x minus 2 factors, we would have a hole in this graph. However, because we do not have any common factors in the numerator and denominator, we are left with no holes within the graph. Next, looking at horizontal asymptotes, we know our rules. If n is less than k, then it's our x-axis. That is our asymptote. If n is equal to k, we know that it's the leading coefficient of the numerator divided by the leading coefficient in the denominator. And if n is greater than k, there is no horizontal asymptote. In this case, we see that we have a x to the 0 in the numerator because x to the 0 is equal to 1. And so we have our n is equal to 0. And in our denominator, we have that x squared, which is a value of 2. And that means k is equal to 2. So we have n, which is less than k, which then follows our first rule here, which says that the x-axis is going to be our horizontal asymptote. If we do that, all we have to do is just dot this line to show that we are not going to touch that x-axis. And there we go. We have our answer. We have that there are no holes. We have that the horizontal asymptote is your x-axis, and we have the vertical asymptote as 2. If we were to graph this, we would be able to approach these lines, but we would never touch them. And there you go. Now you know how to find vertical and horizontal asymptotes given a function. We know that we need to factor both the numerator and the denominator. We need to identify if there are like terms in the numerator and denominator. If there are, then we know that we have holes. If there are not, then we need to solve for the vertical or horizontal asymptote. To solve for vertical asymptotes, you just need to set the denominator equal to 0 and find those values of x that make that statement true. And for horizontal asymptotes, we have 3 rules. We have n, which is the highest degree exponent in the numerator, is less than the highest degree exponent in the denominator, k, then you're going to have the x-axis as your horizontal asymptote. If the highest degree in the numerator is equal to the highest degree in the denominator, you have the leading coefficient of that term, a, divided by the leading coefficient of b in the denominator. And lastly, if n, or your numerator exponent, is greater than k, then there is no asymptote. And this needs to be k, not 0. If you have any questions or comments, please leave them below. If you learned something, please like and subscribe, and we'll see you next time.